Hello everyone, welcome to my YouTube channel 3 battery 1 antenna. In this video we are going to look at how to perform FFT with ESP32. First go to and open a new folder of in the Arduino IDE. Go to sketch, go to include libraries, click on manage library. It will take some time to open. In the search bar, go and type ArduinoFFT. Go and install this first one. I have already installed, so I can't install it again. If you did not install, go and install this library. After installation, close the tab. Again go to sketch, include library, scroll down, and go and add ArduinoFFT library. Let us define some some values. Let us define some variables. The number of samples should be of power 2, means it should be 2 or 8 or 2 or 4 or 8 or 16 or 32 or 64 or 128 or 256 or 512 or 1024, means it should be in the powers of 2. Next, sampling frequency. Sampling frequency should be twice the frequency which we have going to be sampled, means it should be, that is Nyquist criteria. It should be twice the signal which we are going to sample. So I have tested the maximum sampling frequency of ESP32. It will be between 12,000 to 13,000. So I am choosing maximum of 12,000 to 13,000. So I am choosing 10,000 as my sampling frequency. You can choose any sampling frequency between 0 to 12,000 or 13,000. Between 0 to 13,000. Go and create two arrays with size equal to number of samples. Create. This is microseconds is just a dummy variable for a reference which we are gonna use afterwards. And copy this code and make some changes. Near samples, go and number of samples. Near your sampling frequency, go and keep your sample, the variable which you have written as sampling frequency. Void setup, first we have to begin serial begin for printing on the serial monitor. The for loop with I is equal to 0 to I less than number of samples. I plus plus. And we have to assign the real values of the signal and imaginary values of the signal. I have to write analog read and pin number through which you are reading the analog value of the ESP32. So I'm reading from the 32nd pin. So this will be the practical application, but instead of reading it, what I will do is I will hard code a signal for which I have to perform the FFT. I will hard code the signal. Let this be that hard coded signal, which contains three sine waves of different frequencies being added. So the resultant signal will be some audio signal with different frequencies, having frequencies 1000, 500 and 200 with amplitude 150, 30 respectively. So instead of writing analog read, I am hard coding I am giving the input as I am hard coding the input signal. But in real application, we have to write analog read and read the analog value, and for that we have to perform FFT. But instead of doing that, I am hard coding an analog signal and performing a start FFT. Next. So what I'm doing here is I'm waiting until my one by sampling frequency means time period. So I'm waiting till one time period is completed, because the- because this assigning may complete within the single time period. After completing a single, this assignment can be completed before the single time period completes. So we have to wait until the next point of the time period arrive. So we are waiting for that point by using while loop. After this, I'm not writing this code. This is code which is given in the Arduino FFT library. These commands are given by Arduino FFT library. So just copy these codes directly to perform FFT. This first function, what this first function will do is remove the DC component from the input signal. This is our input signal. If our input signal contain any DC component, then we have to write this function. Else just comment this function. So in real situation, when we are reading analog read, we don't know that it may contain or not a DC signal. So it is better to uncomment this command, uncomment this function, and use the function. Next, this function compute performs a fast Fourier transform, and the results will be in complex form. So we have to get the magnitude. So this function converts that imaginary values into real values. For we have assigned our signal to v real of I. So let us print that value in the serial monitor. in the starting of the code we have created this object, right? In this object we are giving the parameter v real and v imaginary. So we have assigned the signal to v real value. So we are printing those v real values here. After performing the FFT, after performing these functions, the complex magnitude which we have computed will be assigned to the v real. So the v real values which we are getting now here is different than the v real values which we are getting here, because after computing the FFT, the values which after the values which you get after FFT will be assigned to the v real array. So the v real now which the v real after computing the FFT value will be the values which we get the FFT results. So printing here v real is printing the audio signal. Printing here v real means printing the FFT output. So that's all the code. Let me check the code and upload the code. I forgot to declare v real and v imaginary. So the code got compiled successfully. Now let us attach the hardware and upload the code. The code is given in the description, or the code will be provided in the comment section. If you did not understand it, just copy the code and make the necessary changes, which I will tell afterwards. Then you are ready to go to use the code. Open serial monitor. That's wrong showing. Okay, this has to be outside of serial. Once again upload the code. So if you want to use this code, just delete this line of code and uncomment this code. Uncomment this line of code and attach the analog input pin and use the analog input pin to input the analog signal and perform the FFT for that analog signal. That's all, and the code will be provided in the description or in the comment section. Just press the reset button. These are the values of the input signal, sampled values of the input signal. These are the output values. I will show you the graph, how it will look. So this is the input signal, hard-coded input signal, which I have hard-coded the signal. This is the hard-coded input signal, green color one, and the red color one is the output signal. So I have added the three sine signal with frequencies 1000, which have frequencies 1000, 500 and 200. So when we perform the FFT, our output should come at 1000, 500 and 200. So let us check that if it has come or not. See, the input is at 1000, output is at 1000, spike is at 1000, 500, and let us zoom. See, another spike is at 200. So our FFT is correct. FFT output is correct. So the spike is at 200, 500 and 1000. So our output FFT is correct. In the next video, I will show how to plot this graph on the display ST7920 so that we can use it as spectrum analyzer. Thank you.